This is the prac for the rates of reaction. That is a compulsory or mandatory prac that is I've made the student experiment for this term. So as you know, there's 4 types of assessment. There's a data test, there's a research investigation, we've done both of those. The third one is the student experiment this term, and in the middle of term 4 we're going to do a 3-hour exam on units 1 and 2. So that's it. So today, very important, we are going to start. So the idea of the student experiment is it is one that you have done, and then once you've done it, for these people here, they're doing it in class, but you would be doing it at home. Once you've done it, you decide how to improve it in some way. So they call it on the assignment, and this is your assignment, the ability to extend it, or to refine it, or to redirect it. So all of those alternatives are based on changing the methodology or the method that you're using to improve it in some way. So just quickly, some safety. You're dealing with hydrochloric acids of different strength. This one happens to be 1 molar, but 2 molar as well. Hydrochloric acid at these strengths is not that dangerous, but you do not want to get it on your skin. So you've got to be careful, and if you do get it on skin, you want to wash it off. If you were to spill it, you neutralise it with the opposite to an acid, which is a base, and the base that you'd have at home is sodium bicarbonate, which is an ingredient of cakes. So watch the acid, be careful. You're going to be reacting an acid with a carbonate. Now this particular carbonate is calcium carbonate. It's marble chips, and when it's ground up into a fine powder, like you can see here, it's actually chalk dust. So you're going to use this reaction, acid plus carbonate, that gives salt plus water plus carbon dioxide, to measure the rate of reaction, because it's very easy to see the bubbling of the carbon dioxide come off and measure the mass difference. So what you're going to do is follow these instructions very carefully, which take you through the different factors that affect rates. So the first one that's on your prac is surface area. So you're going to see how surface area to volume ratio affects the rate, which you probably already know because you've done this many times probably in junior science. The larger your particles, the less reactant can get to all the atoms, so that's going to react slower. If you finely divide something, it has more ability to react with the solution because of the finely divided surface area of this, and so you speed up the reaction. So you sort of already know, so that's one of the factors that affect rates. The other one is changing the concentration of a hydrochloric acid. So to show you that, you're going to be buying your hydrochloric acid at home from a hardware store like Bunnings, and I'm going to give you the instructions for how to dilute that down to say something like 2 molar. But then once you start with 2 molar, you should be able to make any concentration you like by using this formula. So I'll just start very quickly from the most basic concept. Concentration in chemistry is moles per litre, so moles over volume. And when you rearrange that basic equation, you get moles equals concentration times volume. So when you're diluting something, you're adding water. You're not changing the number of moles of substance in there. So it makes sense that CV, which is number of moles, doesn't change. They both equal the same number of moles on both sides. It's only the concentration and the water adding that changes. So C1V1 equals C2V2 you can use. And I've already got an example here. If your first concentration C1 is 2 molar, and you want it to be 1.5 molar, so I'll just put the units in there so you can see, molar, molar. So if you start with 2 molar and you want it to be 1.5 molar, you put this in. You want to know how much of your original to add to your water, so you write V1 because you don't know. And your final total volume you've got to put here. So it's 100 mils in this case. So if you want to work out what V1 is, you then rearrange this equation to make V1 the subject, and you end up with, well, I haven't finished this, had I divided by 2. So it's 150, 1.5 times 100, 150 divided by 2 gives you 75 mils. So what that actually means is you would get your 2 molar HCl, you would measure out 75 mils in a measuring cylinder, and then you would add plus 25 mils of water, and that would make it, and it's got to be distilled water in theory, distilled water, that would make it 1.5 molar. It's no longer 2 molar, so that would then be 1.5 molar, and that's how you do any of your dilutions. So you could change this 1.5 to 0.5, anything you like. If you follow the same method, you know how to do it. So that's the second one on here, and the last one is changing the temperature. You're going to change the temperature of your reacting solution. You've got to be very careful when you're heating acid. So in the lab we use these hot plates. At home, if you're going to use the stove, make sure you're using something that you don't necessarily want to keep, like an old pot or something. Be very careful not to overheat it. Just be mindful that acid, is dangerous, and you don't want it spatting. Of course, you will have your safety glasses on, and you will be measuring the temperature with a thermometer. And that's the basis of this experiment. This tells you to let the experiment go and watch the time. So as it's giving out carbon dioxide gas, it's going down in mass, and you're timing it, and then you can graph the rate of reaction by the evolution of CO2. How you choose to do that, there's many ways, becomes your decision for the student experiment, but you start with this method and modify from there. Any questions? So they're going to get started. Let's do another example. If you had 2 molar to start with, so that is your C1, and you want to know how much to add in order to make a 0.5 molar solution, you need to put V1 there because you don't know what it is, and your final concentration you want is 0.5 molar, and you need to write in here how much you want to make of it. So I might want to make 200 mils, put 200 mils there, and then just rearrange to find out how much of your 2 molar you would need to make up, to change it to 0.5 molar, and then add the rest in water. So V1 is going to be 0.5 times 200 all over 2, which equals 50 mils. So what that's saying is you would have to add 50 mils of your 2 molar plus 150 mils of water to now have 0.5 molar solution.
Rolling already? Oh, okay, so Samantha's going to put the calcium carbonate into the conical flask. I'm going to set it to 0 and press start at the same time, and she'll start recording.
There's like 1 chip here.
Oh, that wasn't calculated. I don't know where that came from.
What's happening?
It's
Gases escaping?
and changing the weight of it.
Oh my god, yeah.
Is it going down rapidly?
Yeah, it's starting to slow now.
Can you get the reading
Hmm.
scales?
Yeah, let's move over slightly. And we stop it when it's stopped moving, like now.
Yes.
Awesome.